Can you transform a word into a dictionary word using only 2 edits? Some work, some don't. But checking all possibilities? That's too slow. Instead, compare letters directly to tree, count differences, and stop once it's more than 2. That one trick makes everything fast. Want the full solution? Check this video.
Hi everyone and welcome back. Today we will solve the lead code problem, words within 2 edits of dictionary. We are given 2 string arrays, queries and dictionary, and all the words in each array are in lowercase English letters and have the same length. In one edit, we can take a word from queries and change any letter in it to any other letter. We need to find all the words from queries that after a maximum of 2 edits will be equal to some word from dictionary. So our goal is to return a list of all the words from queries that match with some words from dictionary after a maximum of 2 edits. We need also to return the words in the same order as they appear in queries. So we are given 2 arrays, queries and dictionary, and for each word in queries, we need to check if we can convert it into any word in dictionary by changing at most 2 characters. And if this is true, we can include it in the answer. So let's look at this example. Here we have queries. It has 4 words, each of size 4, and dictionary have 3 words, also each of size 4. We will iterate over each word in queries and check if we can, by changing at most 2 characters in this word, will it be equal to a word in dictionary. So for the first word, which also is word, if we change the letter R into word to O, this will equal the dictionary word would. So we will include this word in our answer. The same for note. If we change N to J and the T to K, it will equal the dictionary word joke. So we will also include it in answer. For ants, it requires more than 2 edits to equal a word from the dictionary, so we will not include it. And finally, the wood, it doesn't need to change any character because we already have wood in dictionary, so we will include it in answer. So the final answer will be word, note, and wood. The key observation here is that, as you can notice, the size of dictionary and query is not so big. And as you can see, all the words have the same length. So instead of trying all transformation, we can directly compare 2 words character by character. And then we simply count how many positions are different. And if the difference is 2 or less, then we accept this word. So again, here is our strategy. For each query word, for each word in the query array, we will compare it with every word in dictionary. So for example, we will compare the word with wood and joke and mood. And for each comparison, we count the mismatches between the word in query and the word in the dictionary. And if the mismatches exceed 2, we stop early. And if the mismatches is less than or equal to, then we have found a valid match. So we add the query word to the answer. And remember that an important optimization here is the early stopping. The moment mismatches go above 2, we have to break immediately. This saves a lot of unnecessary comparison. So now let's move to the code. I'll create a helper function called is within two edits. So a function that return bool, I call it is within two edits. It will take two strings. Let's name it A and constant string P. It will compare the two strings and count the difference. And as we have said, if the difference exceeds 2, it will return false immediately. Otherwise, it will return 2. So I'll define a variable. Let's call it def, initialize to 0. And then we will iterate over the word for I split down a kit size and plus plus I. We will check if a of I not equal p of I and if it's not equal and increasing the def by 1 is greater than 2. So in this case, we will return false immediately. Otherwise, we will return true. Then in our main function, we loop through each query. So let's first define our answer vector that will hold the final result. Then we will loop over the queries array. And we will loop and then for each dictionary word. So for constant string, let's name it D and dictionary. Then we will call our function is within two edits of Q and D. And if this function returns true, then we will push back or adding the query to the answer. And break. This early break is very important here. And finally, we will return our answer. So let's run it to make sure it doesn't have any errors. Here's problem. Here we go. All the test cases pass. Let's submit it. And as you can see, it beats 100% of the solutions because brute force algorithm here is very valid because, as I said, the searching space is not that big because we are limited by 100 element or word in both queries and dictionary. In terms of time complexity, the time complexity will equal to O of Q multiplied by D multiplied by L, where Q is the number of queries and D is the dictionary size and L is the word length. And Thanks to the early stopping, it performed much faster in practice. And that's it for today's solution. It's simple, efficient, and clean. If you want more optimized problem breakdowns like this, please subscribe to the channel and see you in next one. Bye.